Hi class. I want to use this video as a tutorial on how to solve problems when you have more than one force and what your working equation will look like for that case. So I want you to bring your attention to this situation where you have a pretty large box. It's just sitting on a surface and you just have a person pushing it right here. And this person here pushes this box and they can muster this much force F1 on it. For simplicity, for this video, I would like you to only think about forces that will happen horizontally, that is, only parallel to this blue line right here. We'll later introduce what we're going to do to horizontal forces and what to do when you have horizontal and vertical forces, or vertical forces and horizontal forces. So intuitively, you will know that if this box was at rest, then it will pick up some acceleration this way. And if it was, so therefore, if it's not moving, it starts moving to the right. If it was moving to the right, then it will move slightly faster to the right. So now I want to add another thing, more specifically. I want to add another person. And that person pushes this box opposite. It pushes it with some force 2. Now it's hard to say what the box is going to do, right? It all depends on what these people can do. So we don't know this anymore. Now it all depends. If person on the left is stronger than the person on the right, this box is going to go to the right. If person on the right is stronger than the person on the left, this box is going to go to the left. So mathematically speaking, how do we figure this out? So first of all, we are going to only think about the horizontal forces. Whenever that is the case, it is easier to just call we're going to call a direction positive over here. So this is also a vector here, excuse me. And so what I'm going to say is that if you take force 1 minus force 2 and set it equal to mass times the acceleration, you will find that this equation will work to tell you what the acceleration of this box is. And this sort of makes sense, right? So let's think about it in terms of direction. So this is person 1 and this is person 2. So the mass here is not going to change. So if person 1 is stronger than person 2, this is going to be a positive number that leads to a positive acceleration. Check, that makes sense. And then if person 2 here is stronger than person 1, then the number here is going to be bigger than the number there. So this quantity is going to be minus. When you divide over by mass, you're going to get a negative sign for the acceleration, which is good because if person 2 is stronger, then this box is going to go this way. So that also checks. Now this is for the case of two forces working horizontally. The general case is that you simply say that if I have a sum of all my forces, and what this symbol here means is that you can have 2, 3, 4, 5, 1,000 forces. Sum them all up, and this is a vector sum, and set it equal to the mass of the object multiplied by the acceleration. So the object is going to move, the change of the motion of the object is going to react to the sum of all the forces. Some textbooks call this the net force. It's a very, very common terminology to use. From now on, in this class, this here is going to be our working equation, okay? So let me give you an example on how to work this out. As usual, we're going to have a car. This car is on the level road. And again, for simplicity, I only want to talk about the forces that are horizontal in this case. Okay? So this car right here is actually traveling at some speed already. So this has speed v going this way. V is 70 miles per hour. Its engine applies a force going to the right because you're going down the highway or something, and the applied force here to the right is 2,000 newtons. But since you're going at 70 miles per hour, there's some air resistance here. So this is a resisting force. So force of air resistance here, let's say, is 3,000 newtons. And then the last piece of what you need is the mass of the car. So you need to know that this car's mass, or truck I should say, is 5,000 kilograms, which is kind of heavy for a car. Okay, so now we have a force applied of 2,000 newtons here, going to the right. We have a resisting force of 3,000 to the left. This car is moving at 70 miles per hour with a mass of 5,000 kilograms. I want you to try and find the acceleration. Now, I asked the acceleration vector, so you tell me the acceleration, how much is it, and how much is it, in what direction it is. So go ahead and try to do that. Okay, hopefully you took a shot at it and tried it out, and maybe you already got it. I will go ahead and show you a sure method way of getting this done. First things first, we're only talking about the horizontal forces. So I'm going to decide a direction. And we're going to say whatever points this way is going to be positive. Whatever points the other way is going to be negative. Okay. And then I will go ahead and write my working equation. Mass times, excuse me. Okay. And the first thing I ask myself is how many forces I have. And in this case, we have two. So force applied plus force resistance equals mass times acceleration. Now note, I have not added any negatives here yet because they're vectors. And I want you to get in the habit of doing this. So so this is always the first step. Then the second step is how many forces I have. And once I have how many forces I have, this is always the second step. Now the third step is to get rid of these arrows. And the way you get rid of these arrows is basically an arrow goes away and then either a positive or a negative shows up in front. And that's basically me declaring, turning a vector equation into a scalar equation, into just a number equation. And I do that by basically this sort of encoding of directions I gave myself. So anything that points to the right is positive, anything that points to the left is negative. So if I want to take the force A and turn it into a number, that becomes a positive number, and the resistance force is going to become a negative number. So that's exactly what I'm going to do over here. So applied force becomes a positive number. So I don't have the arrows up here anymore. So this is just a number minus the resistance force equals to mass. And now I'm just going to solve for acceleration in terms of a number, right? If I get a positive acceleration for a number, I know that the car is accelerating to the right. If I get a negative number, it's going to be accelerating to the left. Now, if you have not done this problem, and you didn't know how to begin, you should now be able to do it. But more importantly, where do you think the acceleration will point? Will point to the right or point to the left? See if you can intuitively tell. Okay, so you might have a guess. So let's actually go ahead and solve the problem. So we are trying to find acceleration. So to solve for this is straightforward. You just divide both sides by mass. So you get force applied minus force resistance divided by mass. And then if we remember our numbers, this was 2,000 newtons minus, minus 3,000 newtons divided by the 5,000 kilograms. And the easiest thing here is divide everything by 1,000, so everything just goes away. All these thousands are gone. That's one way to do it. And then 2 minus 3 is minus 1. It's minus 1. So what you end up with is minus 1 over 5. So the acceleration is minus 0.2. The units here is Newton per kilogram. And I'm going to show you the Newton. I'm going to write in green. Newton is a kilogram meter per second squared divided by, and this I'm going to write in blue, kilograms. You see if kilograms will go away, and the only thing I have left is meters per second squared. So the answer here is minus 0.2 meters per second squared. This is the acceleration. It's just a minus in there. And so this acceleration is negative, meaning that the car is slowing down. Does that make sense? Let's check it. Let's check our thing first. I'm going to put this. What is a color I did not use? I'm going to use. So the acceleration ended up being negative, right? So acceleration here equals to minus 0.2 meters per second squared. Does that make sense? I'd say it does. The resistance force is 3,000 newtons, and the applied force is 2,000 newtons. This is almost like a situation in which you're at 70 miles per hour, and you know how much in your pedal it takes to keep it at this speed, and if you let go a little bit, you lose speed, and this is sort of the situation. Where you don't have enough engine power to compensate for the air resistance. Okay, so this is a pretty good method to solve a lot of the homework problems you have this week. So this should clear things up. If you need additional help, please reach out. I'll talk to you all soon, and have a very good day.